Hello all, welcome back to today's class, and I believe we are going to have a great time learning again today. Please pay maximum attention to my explanation. So my focus today is going to be on isosceles and equilateral triangles. Last time we looked at congruent triangles, and we were able to establish that there are 4 conditions for congruency. So I hope you still remember the conditions, because we apply some of the conditions in proving theorem 3. But the proof will not be in this video. I'm going to make another video for the proof to this particular theorem 3. My concern now is on isosceles triangles. By definition, an isosceles triangle has 2 equal sides. The third side is called the base. The equal sides meet at the vertex. The angle at the vertex is called the vertical angle. Is that taken? So here is a picture of an isosceles triangle. So the angle at A here is called the vertical angle. This angle at A. Okay. Now line BC is called the base. All right. And the angle at B and C respectively are called the base angles. All right. Next, equilateral triangles. Equilateral triangles by definition is a special isosceles triangle in which the 3 sides are of equal length. Each angle in an equilateral triangle is 60 degrees. So dashes here implies that they are all of equal length, and you can see they are 60 degrees each. So this is an equilateral triangle. And you've also seen the definition and some of the properties in an earlier video and lecture. So we have 3 examples here. Example 1, 2, and 3. So I'm going to take the solutions to these examples and later give you some exercises to solve. Okay. So here is the very first example. Question 1, it says, isosceles triangles ABC and ABD are drawn on opposite sides of a common base AB. If angle ABC is 70 degrees and angle ADB is 118 degrees, calculate angle ACB and angle CBD. Solution. So here is a sketch of the question. So in this particular section or topic, it is always ideal that you sketch the given question. Produce a diagram for the question so you can solve the unknown. In most of the questions, it will be practically impossible for you to solve it without getting a sketch. I hope that is taken. All right, so here is triangle ABC by the given instruction. We're told that the 2 triangles, the 2 isosceles triangles, has a common base AB, and one of the angle at D is 118, while the angle at C is not unknown, but the angle at B is given as 70 degrees. So this is just a sketch of the question. All right, so we said in triangle ABC, and angle ABC is equal to angle BAC, and it's equal to 70 degrees. What is the reason? These are base angles of an isosceles triangle. You've just seen that in a short, just not long ago. We said the base angles of any isosceles triangles are always equal. So the angle at A in triangle ABC and the angle at B, they must be equal, and they're equal to 70 degrees each. So angle ABC plus angle BAC plus angle ACB equals 80 degrees. That is, angle at A plus angle at B plus angle at C is equal to 180 degrees, using sum of angles in a triangle. So since angle at A and angle at B are 70 degrees each, so 70 plus 70 plus ACB equals 180 degrees. So 70 plus 70 is 140 degrees plus ACB equals 180 degrees. Therefore, angle ACB is equal to 180 degrees minus 140 degrees. And that is equal to 40 degrees. So first problem solved. Next, in triangle ABD, this triangle ABD, I just labeled this part, this side as X and here as X. They are unknown. So X plus 118 degrees is equal to 180. Sum of angles in a triangle. X plus X is 2X. 2X is equal to 180. This will come over to the right hand side. We here is positive. When it comes, it becomes negative. 180 minus 118. 2X equals 62 degrees. We divide both sides by 2 and X is equal to 31 degrees. Now notice that angle CBD, which is the angle here, CBD, the whole of this angle CBD is equal to 70 plus X. Yes, that is angle CBD is equal to angle CBA plus angle ABD. So therefore, CBD is equal to 70 plus 31 because we solve for X as 31. So CBD is 108 degrees. So that is the solution to example 1. I hope this explanation was clear enough. Okay, example 2. Now this says, in an isosceles triangle, or an isosceles triangle is such that the vertical angle is 4 times the side of a base angle. What is the size of a base angle? So I start the solution by saying that let the base angle be X, then the vertical angle will be 4X, of course, since we're told that the vertical angle is 4 times the size of the base angle. So if the base angle is X, the vertical angle will be 4 times X. And here's a sketch of the problem. So that is 4X, X, X. Remember, base angles are always equal. So when you take the sum of the angles in a triangle, you get 180. Reason sum of angles in a triangle, of course. Just put down the reason here. Sum of angles in a triangle. Okay. Next, X plus 4X is equal to 6X, and that is equal to 180 degrees. Divide both sides by 6, X is 30. So hence, the base angle is, or a base angle is 30 degrees. Very, very simple. Finally, question number 3. PQR is an equilateral triangle and QP is reduced to S so that angle or length PS is equal to length QP. Calculate angle QRS. So here's my solution and here's a sketch. So this is a triangle PQR, and we're told that QP is produced to S. So this is QP produced to S. Then I had to connect R to S. So in triangle PQR, angle P is equal to angle Q is equal to angle R, which is equal to 60 degrees. Why? Because that triangle is said to be an equilateral triangle. So we have each angle in an equilateral triangle is 60 degrees. We just saw that in a moment ago. Also, angle RPS, that is this angle RPS is equal to angle TRQ, this particular angle, plus angle PQR, this particular angle. Reason, these are exterior angles of a triangle, exterior angle of a triangle. So that is a very second theorem. So the sum of interior angles of a triangle is equal to the exterior angle. Therefore, angle RPS is equal to 60 plus 60, and that is equal to 120 degrees. Next, in triangle RPS, this triangle RPS, the angle at R is equal to the angle at R, and that is equal to the angle at S, and that is equal to Y. So these are base angles of an isosceles triangle. Also, the sum of the interior angles of this triangle is equal to 180 degrees. Angles are those are sum of angles in a triangle. Okay, so that is P1. the angle at P is 120 degrees. Solve for that here already. That is 120 degrees plus y equals 180 degrees. 120 degrees plus 2y equals 180 degrees. Collecting like terms, we have 2y equals 180 degrees minus 120 degrees. So that is 2y equals 60 and y equals 30. Hence, angle QRS will be equal to QRS, which is the whole of this angle, that will be equal to 60 plus 30, and that will give 90 degrees. All right, so that will bring me to the end of the problem and the end of the lesson under isosceles and equilateral triangles. So the next thing that follows is some exercises. So please endeavor to attempt the exercises that follow. And here are the exercises for the day. Question 1. PQR is an isosceles triangle in which length PQ is equal to PR and P is 58 degrees. Calculate Q. So attempt these problems and please post your answers before the end of the class. Remember how we do it. Solve it in an exercise book in your handwriting. Snap and post. So I'm waiting to get your solutions. All right. Thank you very much. Have a nice time.